Hello, welcome to our next session in SEM. There are always missing data in a questionnaire answers. For example, when a respondent skips a question. The point of missing data analysis is determined to extent of missing data as well as its pattern. There are two questions here. One, what type of missing data are you dealing with? i.e., are the data missing at random, or are there some non-random patterns in your missing data? And two, what to do with the missing data. SPSS missing data analysis help you to determine the pattern of your missing data. You are hoping to have data that are missing completely at random, a situation where a pattern of the missing variables does not depend on any other variable in the dataset. This can be tested using SPSS. The missing value analysis in SPSS can be found in the Analysis menu. And this will help you tabulate the percentage of variables with missing data for each case and the number of cases with missing data for each variable. Missing data under 10% for an individual case can generally be ignored. Cases with more than 50% of missing data should probably be deleted. In the in-between range of 10 to 50%, researchers must apply judgment as to what to do with missing data. There are several approaches for dealing with this problem, including deletion of cases, imputation techniques, and model-based approaches. Given that sample size matters in SEM and that we are trying to retain as many cases as possible, I tend to use imputation technique. Specifically, I substitute missing data with variable mean. Your other choice is to use estimation technique within SEM that handles missing data. Such model-based approaches replace missing data for respondent based on their other answers. Two most common methods are maximum likelihood estimation of the missing values and FIML approach. I'll refer you to Hare et al. For details. I tend to replace my missing data before the analysis. In part, this is a habit acquired when I started working with SEM using a computer software called Lizrel. Lizrel was very unforgiving of any data issues and any other issues, in fact, and there wasn't an option to estimate models with missing data. Now that such model techniques are available, I continue to input data because the software imputation is not without its problems. For example, FIML estimation provides only a small subset of fit statistics that I require for complete evaluation of models. My final point in this tutorial concerns the effect of sample size on data problems. There is little agreement on what is a suitable sample size for estimating SEM, and the proposed guidelines vary depending on the analysis procedures and model characteristics. In general, 5 considerations affect the sample size: normality of data, estimation technique, model complexity, the amount of missing data, and average error variance among the reflective indicators. For example, as data deviate from normality, the ratio of respondents needs to increase to a minimum of 15 respondents for each parameter estimated in your model. For maximum likelihood estimation, that is the default estimation technique in SEM, sample size of a minimum of 200 is recommended. However, as sample size increases and becomes, let's say, larger than 400, the methods become sensitive and almost any difference is detected, making goodness of fit measures suggest a poor fit. As a result, sample sizes in the range of 200 to 400 are suggested as best. Model complexity is another facet that affects sample size. Simple models can be tested with smaller samples. The more indicator variables, the larger the sample you require. Finally, average error variance of indicators matters. That is, it matters how well the items measuring latent construct correlate with one another. Studies show that larger samples are required when communality is small, that is, when the items have little in common, or when unobserved constructs are not explaining the measurement items very well. On page 662 in Hare et al., you will find detailed guidelines concerning the interaction between sample size and other parameters of the model. I will finish this tutorial with an extended checklist for data screening that is based on Tabachnik et al. This checklist includes all the steps you may go through to prepare your data for any multivariate analysis. In the next session, I will talk about data requirements that are specific to SEM and AMOS estimation. See you then. Bye.